The first question, actually the second question of today's lecture. Expand the Fourier series fx is equals to x plus x squared, and the range is given minus pi to plus pi. So after finding the Fourier series, we have to prove that this one, pi squared by 6 is equals to 1 plus 1 by 2 square plus 1 by 3. Once we talk about the Fourier series, it can be defined in the form of, always write formula first, a0 by 2 plus summation an cos nx plus summation bn sin nx. N is equals to 1 to infinity, n is equals to 1 to infinity. So this is a very good question that we have selected. Earlier, directly we got the value of a0, an, and bn. Let's check what happens in this question. So first we compute here what a0. So what is the formula for a0? It is 1 upon pi minus pi 2 plus pi fx dx. So, and fx is what? X plus x square. So it is going to 1 upon pi minus infinity to plus infinity, put the value of x plus x squared dx. Simple integration that we required. So it is going to be 1 upon pi x squared by 2 plus x cubed by 3 and minus pi 2 plus pi. We put the value. So by putting the value, what we get the final answer? It will be pi squared by 2 plus pi cubed by 3. So once we put minus pi, so it will be minus of pi squared by 2, and it will be minus plus pi cubed by 3. So ultimately pi cubed by 3 plus pi cubed by 3. So it is 2 times pi cubed by 3, and pi is here. So it is going to be 2 pi squared by 3. So this is your first value a0 that we get. Now we evaluate the value of an. So always write the formula first. So what is the formula for an? 1 upon pi minus pi to plus pi fx cos nx dx. It will be 1 upon pi minus pi to plus pi, that is the integration. And it will be x plus again x squared cos nx dx. Integration by part that you can use. So this is the one way, that is 1 upon pi integration. This will be the first function, this will be the second function. So it is what? X plus x squared and integration of cos nx. So it is going to be sin nx by n, and the limit will be minus pi to plus pi. This we can take as a common. Minus integration minus pi to plus pi, differentiation of this one. So it is 1 plus 2x. Integration of cos, that is sin nx upon n dx, that we get. So what is the value of sin n pi? Anyone? Once you put the limit, whatever it is, you are putting pi or minus pi. So what is the value of sin n pi?
Sir, वो तो 0 हो जाएगा.
It will be 0, right? So we will have only minus 1 upon pi. Now we apply integration by part here. So it will be what?
एक मिनट
1
सर,
plus
minus 1
2x.
upon pi कहाँ से आया? Sir, can you hear me?
This minus, yes, this minus sign we have taken here. This is
हाँ
zero,
हाँ
ना?
पर सर 1/π वाले लेफ्ट, अच्छा ओके ओके, नहीं नहीं नहीं, मेरे
This
को
minus sign will
ब्रैकेट
come
देखने
here.
में गलती हो रही थी, नहीं नहीं, नो नो प्रॉब्लम सर। हाँ हाँ, नहीं नहीं,
Okay.
मेरी गलती।
So 1 upon 2x by n, that we can take as a what? First function. Now integration of sine nx. So it is going to be minus of cos nx by n, and limit will be minus pi to plus pi, and minus integration again minus pi to plus pi, differentiation of 1 plus 2x. So it is 2. So 2 by n that we can take here, and integration of sine nx, it is again minus of cos nx by n and dx. Okay. Now the thing is, what we can get here. So n square is the common overall, so that we can take minus 1 upon pi n square. Now here it is 1 plus 2x minus cos n pi. So it will be, first you put this value of pi. So it is 1 plus 2 pi, and that we have taken earlier. And it is going to be cos n pi minus 1 minus 2 pi and cos n pi. See, if we talk about this integration, you know cos nx is the even function. This is what? Even function of x. So directly I could write here 0. Okay. So what we get here, it will be equals to, now if we talk about n, so there are two conditions. Okay, so plus 2 pi, and here minus minus plus 2 pi that you can take here. So with 1 cos n pi and minus cos n pi will be cancelled, and 2 pi cos n pi and plus 2 pi cos n pi, that we can take this side. So pi and pi will be cancelled, and what we get, 2 plus 2, 4. So it is 4 by n square. Minus sign is here. It is 2 pi cos n pi, and minus minus plus also that you can take. So it is going to be 4 by n square cos n pi. You can say minus sign we have observed here. So finally, if we are talking about an, so it is going to be 4 by n square if n is even, and it is going to be minus by 4 by n square if n is odd. So what we see difference from the last example, it is what? It is divided into two parts. So an had the two part, 4 by n square and minus 4 by n square. That is depend on the cos n pi. Okay. Next, what we do here, now we calculate bn. So what is the formula for bn? It is 1 upon pi minus pi to plus pi fx sine nx dx. This we get. So it will be equals to 1 upon pi. We will do the same thing here. Minus pi to plus pi x plus x squared sine nx dx. Again, integration by part that you can use here. So it is going to be minus 1 upon pi x plus x squared, and sine n x is what? So it is cos nx, a minus sign that I have taken here. And its limit will be minus pi to plus pi, plus 1 upon pi integration derivative of this, it is 1 plus 2x, because minus minus plus that I have taken earlier, cos nx pi n dx. So this time, if you put pi and minus pi, so it will be what? Again, it will be minus 2 times of cos n pi by n. The result of this you will get. Plus, if we go for this one, so it is again 1 plus 2x by n, integration by part that we can take 2n, and pi that I write here. Integration of cos nx, it is going to be sine nx by n, and minus, okay, limit will be minus pi to plus pi. This will be minus 1 upon this pi, and that we can take here, and it is integration minus pi to plus pi, derivative of 1 plus 2x, so it is 2, and integration of cos nx, so it is going to be sine nx by n dx. So what we get earlier, so this term is going to be 0 again. For this, it is going to be 0. So what we get now, it is minus of 2 cos n pi by n. And what about this one? So what we can write, sine nx is an odd function of x, right? So odd function, you know what happens? The integration minus a to plus a, it is going to be 0. It is going to be 0. So whole term, it is going to be 0. So only minus 2 cos n pi by n that we have. So in this way, what we can write, that is bn is equals to, okay, so this is 2 cos n pi. So again, n is even and odd. So it will be 2 by n if n is odd, and it is minus 2 by n if n is even. So we have calculated all the values. So for fx is equals to x plus x square, what we have, the Fourier series of fx that can be written as fx is equals to a0 by 2 plus summation an cos nx plus bn sin nx. Together also you can write for n is equals to 1 to infinity. The fact is, even and odd it is given. So in such condition, a0 by 2, what was the a0? 2 pi square by 3. So it is 2 pi square by 3 divided by 2. So it is only pi square by 3. It is a0. Plus an. An is what? For even, it is 4 by n square, and for odd, it is minus 4 by n square. So we can, okay, even odd we can take together. So for n is odd, minus 4 by n square. So here I can write here an is minus 4 by n square and bn is 2 by n for n is odd, and bn is an is 4 by n square and bn is minus 2 by n for n is even. So first I write here first term for n is equals to 1. N is equals to 1, it will be minus 4 by 1 square and cos nx. So cos 1x that should be, so it is minus 4 by 1 square cos x plus b1. b1 is what? 2 by 1 sin x plus n is 2, so it is minus 4 by 2 square even, so it is plus 4 by n square, so it is 4 by 2 square cos 2x minus 2 by 2 sine 2x. Similarly, for n is equals to 3, that we can write minus 4 by 3 square cos 3x plus 2 by 3 sine 3x and so on. So this is our Fourier series. Anyway, it is a way of writing only, whether you can take cos together and sine together. Anyway, you can write. Okay, now our next part is we have to show that pi square by 6 is equals to 1 plus 1 by 2 square plus 1 by 3 square, like that. So we know 1 by 1 square, 1 by 2 square, 1 by 3 square, it's the cos x only. And the coefficient of sine x was 2 by 2, 2 by 3, like that. So these are not in the list. So what we do here, if we write here again, if we write f of pi minus 0, so it will be what? Limit h tends to 0, f of pi minus h. No issue, that we can write. So fx is what? X plus x square. So we can write limit of h tends to 0, x is pi minus h, so it is pi minus h plus pi minus h square, that we can write. So once we put the limit directly, h is equal to 0, so it is going to be pi plus pi square. I am not going in detail, so directly that you can write pi plus pi square. If we write f is equal to minus pi plus 0, so in that case also you can take limit h tends to 0, f of minus pi plus h. So it is going to be what? Limit of h tends to 0 and minus pi plus h plus x squared, so minus pi plus h square. Once you put the limit, what we get? It is going to be minus pi plus pi square. So in that case, if you add these two, so by adding some of these two series, both the above values or series that we can say, what we get 1 by 2 f of pi minus 0 plus f of minus pi plus 0. This would be equals to what? 1 by 2 pi plus pi square minus pi plus pi square. And this is what? This is the average that we have taken. So it is going to be equals to what? Pi square. So now we put in the equation here, so in the Fourier series, let's say 1, or we put x is equals to pi in the Fourier series of fx, that is x plus x square. So by putting this, what we get in the left hand side, it is going to be pi square is equals to what is the it is pi square by 3. So it will be pi square by 3 plus. You must know the sign n pi is going to be 0. So we are not worried about sign term. We are worried about only the cost term. So it is going to be 4 is everywhere. So that we can take common. Minus 4, you can merge with the minus term that you can merge with the cos x. No issue. So all term that you can make the positive. So 4 if you take common, and cos pi is 1. So in that case, it is going to be what? 4 times 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square and so on. And plus 2 into 0 for the sin x that we can write here. So ultimately, if this goes this side, so pi square minus pi square by 3, and here it is 4 times 1 by 1 square plus 1 by 2 square plus 1 by 3 square and so on. So it is going to be what? 2 pi square by 3. And this 4 you can take this side. So it is 4. So ultimately it is going to be pi square by 6. And it is equals to 1 by 1 square plus 1 by 2 square plus 1 by 3 square and so on. So this is our required result. Now we will see this question number 3, and the second question for today's lecture. Expand the Fourier series. Fx is given minus pi for minus pi to 0 and x for 0 to pi. It means function is what? Broken in 2 parts. Minus pi to 0 integration, we have to integrate minus pi, and 0 to pi we have to integrate x. And as usual, after having the Fourier series, we have to prove this series. So again, it is a little bit different from the previous one. So solution point of view, the Fourier series of fx can be given as what? Fx is equals to a0 by 2 plus summation an cos nx plus bn sin nx for n is equals to 1 to infinity. And we have to find this all values a0, an, and bn. To compute this, what we go? A0. What is the formula for A0? So 1 upon pi integration from minus pi to plus pi. The range is minus pi to plus pi. Fx dx. So it will be what? 1 upon pi and integrate into 2 part, minus pi to 0. And it is value of fx is minus pi dx plus Or you can also write 1 upon pi twice or take common. 0 to pi x dx. Minus pi and plus pi that you can take outside. Minus pi upon pi. Integration of 1 is x, limit is minus pi to 0, plus 1 upon pi. It will be x square by 2, 0 to pi. So what we get here, this will be minus 1. If you put 0, minus plus pi, and minus 1. So it is going to be minus pi plus. It will be what? Pi square by 2. So pi and pi will be cancelled. So it is pi by 2. So finally, a0 is what? Minus pi by 2 that we get. So always finding a0 is very quite easy than the an and bn, because the multiplication with cos nx and sin x is there. But don't worry, in coming lecture, it will be going to be easy, very easy.
Yeah, Fourier series?
Yeah, the calculation of an is going to be very easy in coming lectures, not today. Today I have to calculate, but some property when we apply, it will be easy. 1 upon pi minus pi to plus pi fx cos nx dx. Again, it will be integrated into two parts. 1 upon pi minus pi to 0, so that it is minus pi cos nx dx plus 1 upon pi 0 to pi, and value of fx is x cos nx dx. Okay. So again, minus pi by pi that you can take outside. Minus pi by pi or minus 1 you can take. Integration of cos nx. So it is sine nx by n, and the limit will be minus pi to 0 plus 1 upon pi. It will be what? Integration by part that we have to apply. So it is x sine nx by n 0 to pi minus either you can apply separately. If we are writing this one, so this will be the limit part. So 1 by pi will be cut. So it is what? Integration differentiation of x 1, integration of cos nx. So it is sine nx by n dx. Okay, sine 0 is 0, sine pi is also 0. So it whole term will be 0. What about this? This is also 0. So only this term we have left. So it is minus 1 by n pi that we can take outside. Okay. So and sine nx, integration of sine nx. So it is cos nx by n, but the minus sign should be there, 0 to pi. So it is going to equals, and we can take outside. So it is 1 upon n square pi, and minus sign should be there. So minus plus that you can take. Okay. So it is cos n pi minus cos 0 is 1. So ultimately, it can be written as 1 upon n squared pi. What is the value of cos n pi? So it is minus 1 to the power 2, minus 1 to the power n minus 1. That we can write. So again, we get the value of an, that is, if minus 1 is minus 2, so it is minus 2 by n square pi. The condition is n is odd. And no doubt it is 0 when n is even. So after finding a0 and an, we will go for finding what? bn. Now, to calculate bn, it is 1 upon pi integration minus pi to plus pi fx sine nx dx. Again, in two parts we will integrate from minus pi to 0. So for that, fx is minus pi sine nx dx plus 1 upon pi 0 to pi, and for this it is x sine nx dx. Again, minus pi and pi, that we can take minus pi upon pi. Integration of sine nx, so it is minus of cos nx by n, and limit will be minus pi to 0 plus 1 upon pi. Okay, integration by part that we can take, so it is x cos nx by n minus sign we can take 0 to pi, and minus differentiation of x is 1, so it is integration 0 to pi minus of cos nx pi and dx. So what we done right here, what is the value of cos n pi? Okay, so this can be written as here minus minus plus, so it is 1 by n. Once we put the 0, the cos 0 is 1 minus cos n pi. Just a minute. Cos n pi, okay, plus 1 by pi. Once we put here again this one, so it is going to, okay, once we put 0, no, so it will be 0. So it is going to be what? Minus of pi, and pi will be 1. So it is cos n pi, and pi will be cancelled. So it is 1 by n, that we can write. Minus integration 0 to pi plus that we can write now cos nx by n dx. So what we get, 1 by n is the common. It will be 1 minus 2 times of cos n pi. And okay, 1 by pi have to write here. So plus 1 by n pi 0 to pi cos nx dx. Can I write directly this term is 0? Because cos will be sine integration and 0 pi, that will cancel. So finally, what we have only, it is 1 by n, 1 minus 2 cos n pi. Cos n pi, that we can write minus 1 to the power n. So ultimately, therefore, b1 will have again two value. If it is odd, so it is what? 3 by n. So if it is odd, so it is 3 by n. N is odd, and if it is even, it is going to be minus 1 by n if n is even. So thus we get the value of A, B, and C. And an is what? An is only minus 2 by n square pi for n is odd. Otherwise 0 for n is even. And what is the value of A0? A0 is what? Minus pi by 2. So thus in the Fourier series, what we get here, so fx can be written as A0 by 2 plus summation an cos nx plus bn sin nx for n is equals to 1 to infinity. A0 is minus pi by 2, so no issue, it is going to be minus pi by 4 plus. What about an? An is only odd terms is there, so minus 2 by pi that we can take outside. It is minus 2 by pi that you can take outside, and only the odd number. So 1 upon 3 squared plus 1 upon 5 squared, like that. So it is going to be 1 upon 1 squared plus 1 upon 3 squared plus 1 upon 5 squared, and so on. Plus bn. Okay. And cos nx. Okay, wait. This should be 1 upon 1 squared cos x plus 1 upon 3 squared cos 3x plus 1 upon 5 squared cos 5x, and so on. Plus, what about bn? It has the even and odd 3 by n and even for minus 1 by n. So what we can write 3 by n and minus 1 by n. So it will be 3 by n 1 sin x minus 1 by 2 sin 2x plus 3 by 3 sin 3x minus 1 by 4 sin 4x, and so on. That can be written. Now we have to find this value. So we can check here. It is 1 by 1 square, 1 by 3 square, 1 by 5 square, like that. So directly we know for x is equals to 0, it will be 1 by 1 square plus 1 by 3 square plus 1 by 5 square. And at x is equals to 0, all the value of sine will be 0. So if it is Fourier series, so we put here x is equals to 0 in 1. We get. Okay, if x is equals to 0, so again we have to move forward. For fx, limit x tends to 0, fx will be what? 1 by 2 f of 0 minus 0 plus f of 0 plus 0. So in both case, if we say 0 is the middle value, no? So in this way, it is going to be minus pi. So only minus pi by 2 that you can get. So by putting x is equals to 0, what we get? Minus pi by 2 is equals to minus pi by 4 plus minus 2 by pi, not 3. Minus 2 by pi. And it is going to be 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, and so on. So by having this minus pi by 2 plus pi by 4, so what we get here, it is pi by minus pi by 4 is equals to minus of 2 pi 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on. So by summarizing it, so what we get here, 4 2 ja 8, minus minus sign is plus. So this implies pi square by 8 is equals to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, which is the required result. Which is the required result. Any question?
No, sir.